Just a few days ago, one of the pro members shared a website under the Video Ideas channel highlighting a section with an incredible scroll sequence. This site was featured as an honorable mention on awards back in June. The animation we'll be focusing on today is the spotlight section, where a set of text blocks, basically product features, morph together on scroll, forming a search bar style element that syncs perfectly with a new header reveal. I thought this could be a really useful scroll timeline, something you can easily repurpose for any SaaS website. It's a clean way to showcase your app's core features in motion instead of keeping everything static. So last week, I decided to give it a try and see if I could recreate that same scroll sequence from scratch. After spending a few hours experimenting, I managed to put together this version, which captures the core animation concept using simple HTML, CSS, and JavaScript powered by GSAP and ScrollTrigger. In this video, I'll walk you through exactly how it works and how you can craft similar scroll-based timelines using ScrollTrigger's on-update callback. If you find these kinds of rebuilds helpful, make sure you leave a like on the video and subscribe to the channel if you haven't already. And if you'd like to access the source code for this project, plus hundreds of other similar micro projects, and a brand new website template every month, you can check out the Pro membership via the link in the description. Alright, let's jump into the code. First, I'm creating two sections, one for the intro and one for the outro. This just gives the page a bit of structure and enough vertical range for the scroll animation. Inside both, I have added a simple heading element, just some placeholder text so the page doesn't feel empty while we scroll through. Now between those two, we'll create the main spotlight section. This is where the entire sequence takes place. Inside it, I am starting with a div called Spotlight Content. This will contain the initial content that appears when the animation starts. Inside that, I am adding another div with the class Spotlight Background, which holds an image, and right below it an h1 element. This part will animate out as soon as the scroll sequence begins, making space for the next phase. Next, we'll add another container called Header. Inside it, I have placed a wrapper named Header Content. This will hold the heading and a short paragraph. We'll animate this block in later during the final stage of the scroll. Now comes the key section, the features. Each feature is represented by a single div with the class name feature. Inside it, there are two nested elements, one called feature background and another called feature content. The background div lets us animate size, shape, and borders independently without affecting the text or layout. It just keeps everything cleaner and prevents any line breaks while we scale or morph these blocks. Once the structure is set, I'll duplicate this feature a few more times and update the inner text, giving us multiple features to work with. Later in JavaScript, we'll dynamically position each one across the section so they start scattered around the viewport. Finally, we'll add one last element for the search bar. This is a single div with the class name search bar and inside it a paragraph element. Using ScrollTrigger, we'll later create a seamless handoff between the feature blocks and the search bar so it feels like they merge into one. And that's it for the HTML. Next, we'll move on to the CSS and start styling everything for the scroll-based transitions. First of all, I'll import the fonts that we'll be using across the page, a serif for the large headlines, a monospace type for the feature labels, and a clean sans serif for the smaller text. This mix gives us a nice contrast between structure and clarity and sets the tone for the design. Next, I'll define a few color variables inside the root. We'll create a simple palette of deep grays for the background and borders and a light neutral tone for the text. That will keep everything minimal and consistent throughout the animation. Then I'll remove all the default margins and paddings and make sure every element follows the same box model just to keep the layout predictable when we start animating. Now I'll style the body. We'll apply the serif font as the main typeface, give the page a dark background and use light text on top. It keeps the layout simple and lets the animation stand out clearly. For images, I'll make sure they always fill their containers and crop neatly. Next, I'll style the main headings. They'll sit centered on the page, use large typography, and have tight line spacing, giving them that bold, intentional look. For paragraphs, I'll switch to the sans serif font, slightly smaller and cleaner, just to create a nice hierarchy under the headings. After that, I'll set the base layout for every section. Each section will take up the full height of the screen and hide any overflow. That way, all of our animations stay contained within the viewport. Now for the intro and outro sections, I'll center their content both vertically and horizontally and add some internal padding so the text has breathing room. This just frames the scroll sequence nicely. Then I'll move to the spotlight section. Both the spotlight content and the header will be positioned absolutely so they overlap in the same space. We'll keep them centered and use Flexbox to align everything perfectly in the middle. This setup will let us transition smoothly between them later when one moves out and the other fades in. Inside the spotlight content, I'll slightly scale down the background mesh and give it low opacity so it feels subtle and atmospheric behind the text. The main headline inside this block will have a defined width so it sits nicely in the center without stretching too wide. Next, I'll style the header content. It will also stay centered but use a vertical layout with some spacing between the heading and paragraph. I'll start it slightly offset upward and keep it transparent by default so we can animate it in later during the final phase of the scroll. Now I'll move to the features. Each feature will be absolutely positioned, padded slightly, and centered around its top and left coordinates. This makes it easy to move them toward the center later using GSAP. For the feature background, I'll use a muted dark tone with a thin border and rounded corners. We'll also mark this layer as we'll change for width, height, and radius so the browser can optimize it for the morphing animation we'll be doing in JavaScript. Inside that, the feature content will hold the label text. I'll set it to uppercase using the monospaced font so all the labels look consistent and technical. After that, I'll style the search bar. We'll keep it absolutely centered on the screen, starting small and circular with no text visible at first. It will have the same background tone and border style as the features, so when they morph together, it feels like a natural continuation. We'll later animate its width and height with ScrollTrigger to create that smooth transformation effect. Inside the search bar, I'll fade the paragraph out completely and slide it slightly to one side. We'll bring it in later once the final header starts to appear. Finally, I'll add a responsive block for smaller screens. When the viewport width drops, I'll scale down the headings, increase their padding, and let them take the full width of the screen. I'll also zoom out the mesh background slightly so it doesn't overpower the text. The features will get smaller padding and their label size will reduce just enough to stay readable on mobile. That's it for the CSS. We have styled every layer, prepared all the elements for animation, and made sure the layout stays responsive across devices. Next, we'll move on to the JavaScript and start wiring up the scroll logic with GSAP and ScrollTrigger. Before we start writing the JavaScript, let me quickly walk you through the overall approach, just so you have a clear idea of how we are going to build the scroll animation step by step. We are going to handle the entire sequence using a simple pinned scroll trigger timeline. This will give us full control over the animation as the user scrolls, and we'll use the onUpdate callback to control each phase manually based on scroll progress. First, we'll pin the section so everything plays out in one spot while the rest of the page stays frozen. Then we'll move the initial spotlight headline upward, syncing its Y position to the scroll so it scrolls out of view as the animation begins. Next, we'll leave the feature blocks visible and gradually animate each one toward the center. We'll use the top and left values for this just to keep the positioning simple based on how the layout is structured. While they move, we'll also shrink their background sizes, so by the midpoint, they all come together and form a compact circular cluster. Once they reach the center, we'll hide all the feature blocks entirely, and at the same moment, we'll reveal a new element in the same position. This will act as the base for the search bar. Because the layout and styling match, the transition will feel seamless, like nothing changed. Then we'll animate the new element's width and height, so it stretches out into a pill-shaped search bar. Once it settles, we'll fade and slide in the final header and bring in the search text to complete the sequence. Finally, we'll unpin the section and the user continues scrolling down the page like normal. So that's the plan. Now that you have a rough idea of how we'll approach this, let's start building it out step by step. First, I'll import everything we need for this animation. We'll bring in GSAP to handle all the animations, ScrollTrigger to sync those animations with scroll progress, and Lenis, a lightweight smooth scroll library that gives us that soft, buttery motion. Then I'll wait for the DOM to fully load before running anything, just to make sure all the elements are available before we try to target them. Inside that block, the first thing I'll do is register the ScrollTrigger plugin with GSAP. This is required anytime we are using ScrollTrigger, otherwise the animations won't sync properly with scroll. Next, I'll set up Lenis. I'll create a new instance and tell it to listen for scroll events. This gives us that smooth, inertia-style scroll behavior. After that, I'll connect Linus to GSAP's internal ticker, so GSAP knows exactly when to update and how to track scroll progress in sync with Linus. You can find this exact block of code on Linus documentation. I just grabbed it from there, and you can too. After that, I'll grab all the feature blocks and store them in a variable. Then I'll do the same for all the feature background elements inside them. We'll animate both of these later, the outer containers for positioning and the background layers for width, height, and radius. Now we need to define the starting positions for each feature, so I'll create an array of objects that holds the top and left values for every feature block. Each entry represents one of the 7 features, and these values are written in percentages based on the height and width of the section. Later, I'll use this to place each feature around the screen before they start moving toward the center. That's the initial setup. Next, we'll set the position of each feature based on this array and start measuring their sizes so we can animate them cleanly into a unified search bar later. Alright, first I'll loop through all the feature elements one by one. For each one, I'll grab the corresponding top and left values for the feature start positions array. Then I'll set those values directly using GSAP, placing each feature block at the right spot using percentages. This is what scatters them around the viewport when this section first loads, so we start with a more dynamic layout instead of everything sitting at the center. We are using top and left here instead of transform based positioning, mainly because this layout is absolute and we want full control over where each block lands. Usually it's recommended that we animate the transform values when we move around the elements using GSAP, but given the nature of the layout, it's a bit easier to animate just top and left to get the animation ready. It's not the most performant way to animate, but it works well for this kind of visual layout when we want to place the elements scattered across the page. Next, I'll create a new array called feature start dimensions. This will store the real size of each feature background before any animation begins. I'll loop through all the feature background elements and call getBoundingClientRect function on each one. That gives me the current width and height in pixels of every block as rendered on the screen. Then I'll push those values into an array one at a time. We'll use these later when we animate the size of each feature, specifically when we shrink them down and morph them into a consistent circular shape before the search bar appears. Now, we also need to define the target dimensions that we want all features to collapse into. So I'll calculate the pixel value of one rem by grabbing the computed font size of the root HTML element. Then I'll multiply that by 3 just to give us a consistent circle size that works across devices. I'll store those two values, one for width and one for height, and this becomes our final shape for the collapsed features. Later, as you animate each block inward, we'll interpolate from the original size we just captured into these target values so the transformation feels smooth and balanced no matter what screen size the user is on. Next, I'll create a function called getSearchBarFinalWidth. This checks the current screen width, and if it's under a certain breakpoint, I'll return a slightly smaller width for the search bar. Otherwise, I'll return larger width that looks better on desktop. This way, we can dynamically size the final search bar depending on what device the user is viewing from without breaking the layout or animation flow. Right after that, I'll call the function once and store the value in a variable. We'll use this later during the search bar morph animation when we stretch it from a circle into a pill. Finally, I'll add a resize event listener on the window. Whenever the browser is resized, I'll rerun that same function and update the width value accordingly. And I'll also call ScrollTrigger refresh function to make sure all the pinning, scroll distances, and animation ranges stay perfectly in sync after the layout shifts. That's everything we need to prep for the animation, positions, dimensions, morph targets, and responsive behavior. Next, we'll create the main scroll trigger and start animating everything based on scroll progress. So I'll create a scroll trigger and pass in all the settings we need. For the trigger, I'll use the spotlight section. That's the wrapper that holds everything we are animating in this build. Next, I'll set the start point to start, which means the animation begins as soon as the top of the section hits the top of the viewport. Then I'll set the end value to span across 3 full screen heights. That gives us enough scroll distance to space out the entire sequence across multiple phases. After that, I'll pin the section so everything inside stays fixed on the screen while the animation plays. I'll also enable pin spacing to keep the document height consistent and prevent layout jumps. Then I'll turn on scrub. This ties the animation directly to scroll position, so every motion plays forward or backward in real time depending on how the user scrolls. Finally, I'll use the onUpdate callback. This gives us access to the scroll progress as a value between 0 and 1. Every time the scroll updates, this block will run and will manually update each part of the animation based on the current progress. So first, I'll check if the scroll progress is still in the opening third. That's the part where we slide the initial headline out of view. If it is, I'll calculate how far we are into that range and store it in a variable. Then I'll use GSAP set method to move the spotlight content upward based on the progress value. This creates a smooth transition where the opening headline and the background image scrolls out of the way as the user scrolls down. If we have already passed that first third, I'll snap the headline fully out just to make sure it doesn't linger on screen once we enter the next phase of the sequence. That's the first stage of the scroll trigger, removing the spotlight header and the background image cleanly. Next, we'll start animating the features toward the center. So I'll check if the scroll progress is within the first half of the timeline. That's the range where we animate the features inward and shrink them down. First, I'll calculate how far we are into that half using a feature progress value. This will go from 0 to 1 as we scroll through the first 50% of the timeline. Then I'll loop through all the feature blocks one by one. For each one, I'll grab its original top and left values, which we set earlier using the feature start positions array. Then I'll interpolate between those starting values and 50%, which is the center of the screen. So as the scroll progresses, each feature gradually shifts from its original position into the middle. I'll use GSAP set method to update the top and left positions in real time, frame by frame. This is what creates that converging effect, all the feature blocks moving together toward the same point. After that, I'll do the same for the background layers inside each feature. This time, I'll take the original width and height of each background and interpolate that into a smaller circular target size we calculated earlier. So each block not only moves toward the center but also shrinks down at the same time. While we do that, I'll also animate the border radius so it gradually rounds off and becomes a circle. And I'll increase the border width slightly just to give it more visual presence as the size comes down, which should match the border width of the search bar we defined in CSS. Altogether, this creates that effect where all the blocks collapse into the center, forming a smooth, compact shape. Now as we start the invert motion, I'll also fade out the text inside each feature, so I'll check if we are in the first part of the 0 to 50% range, just the first 10%. I'll calculate how far into that we are and then reduce the opacity of all feature content elements. That gives us a nice effect where the labels fade out as the features begin moving. So by the time they reach the center, only the block shapes remain. If we scroll past that 10% mark, I'll just snap the text opacity to 0 so they stay hidden for the rest of the timeline. Once we pass the halfway point, I'll completely hide all the features. This is the moment where we do the handoff to the search bar. So I'll set the opacity of the entire features wrapper to 0. And at the exact same time, I'll reveal the search bar element by setting its opacity to 1. Because the styles match and both sit in the same position, this feels like a seamless swap. The features disappear and the search bar appears in the center place. This completes the full feature block animation and transitions us into the next phase, where we'll stretch the search bar into a pill and reveal the final content. Alright, next we'll check if the scroll progress is between 50% and 75%, which is when we want to animate the shape change of the search bar. First, I'll calculate how far we are into this specific segment using search bar progress. It goes from 0 to 1 during that 25% range, so we can interpolate things smoothly. We'll animate the width and height of the search bar element, starting from a 3rem circle and stretching it outward horizontally. The final width depends on screen size. We calculated that earlier using getSearchBar final width. For height, we are taking it from 3rem up to 5rem, so the pill gets a bit thicker too. At the same time, we'll animate the vertical position using a translate Y. It starts from the center and moves downward a little bit of the screen. All these changes, width, height, and translate Y, happen at the same time, giving us that satisfying morph effect from circle to search bar like shape. While that's happening, I'll also keep the paragraph inside the search bar hidden, so I'll set its opacity to 0 throughout this stretch. Now if we have already scrolled past 75%, I'll just snap the search bar to its final dimensions and position so we don't get any weird in-between states if the user scrolls quickly or resizes the screen. Once we cross into that last 25%, from 75% to 100%, we begin the final reveal. I'll calculate another progress value, this time called final header progress, to control the fade-ins. Using that, I'll animate the opacity of the paragraph inside the search bar so the search text fades in gracefully. Then I'll reveal the header content element. This is the final headline that completes the animation. We'll animate both its opacity and Y position so it slides upward into view and lands softly. If we haven't reached that final stretch yet, I'll keep both the search bar text and the header hidden, just to make sure nothing appears too early. This brings us to the end of the animation sequence, where the spotlight ends and the interface lends into a new static state, ready for whatever comes next. Hope you found the video helpful. See you in the next one.